Yes, like it's differ how like in photons. It's good that you asked the question. In photons, you have indirect action, whereas in heavy ions you have the direct action. Indirect action means that you interact with the water molecule, then it produce OH and electrons, and those electrons again interact with water, and then they produce what do you call this? Like the what do you call it, like OH free radicals. Yes, free radicals. So that's how that is the indirect action, whereas in these protons or heavy ions, they directly hit the DNA and interact with the electrons of the tissue, and that's the difference between heavy ion and the photons. Yes, in this simulation, like we can simulate the actual thing there. So you can send the beam, and you can have the modulator, and then you can calculate the results, and like it's kind of actual virtual, but it's pretty good, I guess.
I think this technique actually is still in the research stage.
Yes.
Is that correct?
Yes, still in the research stage, but they are still now they are using it in developed countries.
Yeah. Actually, this is the new generation of. I think probably you have heard of CyberKnife, right? That is where precisely they deliver a beam of radiation into certain areas where it is operable. But here it is. They are mainly concentrating on inoperable sites. Is that correct?
Yes, we call it like pencil beam scanning.
Exactly. Yeah.
Yes.
Yeah. So it's a next step of CyberKnife, like so. Still, it's photons, basically photons.
So that's the problem. That's why I said like it costs billions of dollars, because now you have to have you have the carbon particle. You have to accelerate it. So using cyclotrons or accelerators. So for that, that's the biggest cost goes for. So to build those cyclotron, that's the biggest cost goes for. Like then you rotate it, and then you get to the energy. So I say like 200 or like 300 MeV, then you use it as a radiation, because you accelerate it up to like 0.7, of the speed of the light.
Can you use C11 also there?
Sir?
C11, can you use C11?
C11, well, the half-life of C11 is like 27 minutes or something like that.
Yes.
So, but I'm not sure. Normally they use C12.
C12, yes.
So I don't know with the half-life and all that. We can because it's again a radioactive, and I'm not sure though.
You're not
Not sure though whether we can use C11. C12. Like I can't remember exactly like it's much more.
Much longer.
It's not radioactive though. So.
Yes. Yes.
Yeah. Yeah. Which one? This one? Or hmm? Okay. So sorry. Yes. because like you have very small like millisievert, like it's very difficult to scale them. Even like you have a nice picture here, like it's very difficult to scale it out in the normal axis. Oh yes. You are right. I'm totally wrong. Yes, this is normal. The next one I choose. Actually, I tried Semilog there, but I couldn't find any relationship.
But you should have shown that because
in the next one, again you can see that I chose Semilog.
Yeah, you see a trend here because you use the log axis for the y-axis. So at least you should have used the y-axis in log in the previous graph for the sake of better comparison.
Well, that's true, but actually I did that, but I couldn't find out any simple relationship.
Normally you don't see trends with numerical axis. Right? I don't have to tell this thing to you because you are a physicist. Anyway, good luck. It's a good study.
I tried that, but I couldn't find any simple relationship.
You should have shown that. Okay, thanks.
Any more questions? There's some more time left. Okay, right. In the absence of any questions, thank you very much, Mr. Evadikaram, and all three presenters here. Now it is time to wind up. I think this session addressed one basic issue in our radiation practice or discipline. We have a principle called ALARA, that is as low as achievable. So I think all three papers try to illustrate the safety and the radiation protection aspect of this exercise or our practice. So I congratulate all three of choosing this subject and try to highlight certain problems, shortcomings, and what can we do in our setup, because we know that we have limited resources and limited facilities in our health setup. So to address certain issues there, I think this kind of observations, this kind of research is essential. So I think it's well done by all three people, and I must excuse me, congratulate the Vice Chancellor and the Dean of this faculty for giving this opportunity for these young scientists to come up and discuss their findings. Maybe it is the baseline or maybe the foundation for certain other good innovative products later on. So I congratulate all three of you, and I think this the fact that the what we practice as ALARA or the as low as achievable in radiation delivery. So always we have to keep in mind that we have to respect our patients and end users. So the one way of respecting them is to give the minimum radiation dose as radiation workers, because they are frightened most of the time when they come for the Department of Radiology or nuclear medicine. They are frightened because they know that we are giving radiation. So they ask various questions. as a practicing practitioner, you must know your limitations and what kind of answer suits the patient's mentality. So that is very important. I think by doing some kind of research and practicing evidence-based medicine, I think you can get a lot of answers for those questions. So I congratulate once again, and well done.
Thank you, sir. So to wrap up the proceedings, I would like to invite Dean of Faculty of Allied Health Sciences, Colonel Dr. P.T.R. Makulolua, and also the Chairperson, Dr. James Udugama, to hand in the certificates of participation. So for the paper on testicular radiation dose during KUB radiography, I would like to invite C.J. Horidigala. For the paper on assessment of evidence-based practice among graduate radiographers, I would like to invite Mr. M. Jayasudhan. And for the paper on in-body stray neutrons produced in carbon and proton radiation therapy, I would like to invite Mr. D.K. Hevadikara. Now it's time to hand over the certificate and the plaque of the participation to the chairperson, Dr. James C. Udugama. Madam, if you please. Thank you, sir. Thank you, ma'am.